Good afternoon. Today we are going to see two problems on cables and that from 2022. Now you can go to this Civil Engineers Technical Hub, and in playlist you can have more videos on engineering mechanics. So now in this, if we will see this cable ABCD is loaded and supported as shown in figure, if DC equal to 0.75 and DB 1.125. So DB we have 1.125 and DC we have 0.75. And then determine the component of reaction at A and maximum tension in the cable. So now first we will find angle that is at A. So we have tan inverse of 1.125 divided by 2, 29.36 degrees. And at C, we have this angle. And this angle we have 36.86. And now we will solve this. So we have this angle 29.36. And this angle 36.86. Now we have a reaction over here which is VA, always upward, and at D also we have always upward, which will be VD. Means if I will draw this on this side, so we have in this fashion. So now we have a reaction over here. So this is VA. And always your reaction at left support is towards the left because we have tension in the cable. And our tension arrow is away from the joint, which component of this X component is towards right. And if we will go to right support, then we have reaction upward, VB, and as we have tension in the cable, so component of this tension is towards the left. So reaction, horizontal reaction at D, this is D. So at D is towards right. So now we have force here 22.5 kilonewton. And at B, we have 30 kilonewtons. Now we have distances. These are given 2 meter, 2 meter, 1 meter. So I will take moment about D equal to 0. And we have 30 into this distance, 3 meters. So we have 30 into 3 minus, because anti-clockwise, minus 22.5 into 1 plus VA into 5, and we have that is 0. And from this we will get VA equal to 22.5 kilonewton. So VA we have 22.5 kilonewtons. Now apply Fy0. So we have 22.5, which is VA, minus 30, minus 22.5, plus VD equal to 0. And from this we will get VD equal to 30 kilonewton. So VD 30 kilonewton. Now we have this angle 29.36. So if I will consider joint A, then at joint A, I have this reaction which is 22.5. This cable we have that is 29.36. This is TAB, and we have this as HA. Now, if you apply FY0, then we have 22.5 minus TAB sine 29.36 equal to 0. And we will get, therefore, TAB we will get equal to 45.89. 45.89 kilonewton. Just I will check, divide by sine 29.36. Now HA we can find by considering summation fx0. So we have, now TAB we have 45.89. So we will get HA equal to 45.89 cos of 29.36. And we will get this value equal to 29.36. So 40 kilonewtons. So we have this value 40 kilonewtons. Now, as we have no horizontal force acting on this, so my value of HA, which is 40, should be equal to value of HD, 40 kilonewton. And then we have this angle that we have calculated, that is 36.86. Now you can find, now if I will consider joint D, then we have this joint. So I have now, this is 40. And then we have, this is VD, we have calculated 30 kilonewtons. And we have, this will be tension TDC. Now this angle we know, which is 36.86. So you can write Fx or Fy, you can write anything. If I will write summation Fx equal to 0, then we have TDC cos 36.86, that is equal to 40. And TDC we will get 40 divided by cos 36.86, which will be 50 kilonewtons. If you have seen my video of this cable before this, then you can see where we have greater angle, in that we have larger force, because your value of cos theta, so that increases from cos 0, we have this value 1, and we have cos 90, this value 0. And if you will see this relation, in this relation, if I will write, then I have this relation, that is TDC equal to HA upon cos theta D. And if you write TAB, then you have H. So this is HA equal to HD. So I have mentioned HA. So this will be HA divided by cos theta A. So as theta D angle, we have higher side, and therefore this value I already mentioned. So we have this value cos 36.86 is 0.8, and cos 29.36 is 0.87. So as you are going from 0 to 90, this is 1 to 0. So as your angle go on higher side, your value of cos theta reduces, and tension near that cable will be larger. So you have to see angle at A and angle at D, where you have larger angle, at that support, you will get more value or maximum tension in the cable. And we have maximum tension CD, in CD, that is equal to 50 kilonewton. Now, in the same fashion, we can solve this problem also. Try to understand the concept of this cable, and then you will able to solve this problem. Now we have given value of HB is given. How much it is given? 1.8 meter. Now we can find this angle. So what we will get? Tan inverse of 1.8 upon 3. So we have shift tan inverse 1.8 divided by 3 is 30.96. And now we will solve this. So now you can see this. So I will draw this cable 334. So we have, so this cable we have, and here we have again upward. I already mentioned this will be left side, this will be upward, and this we are on right side. Then this is downward force. We have this force, we have downward, and we have this value 6 kilonewton, 10 kilonewton, 10 kilonewton, and distances these are given. If you will see in the problem, so we have first distance 3 meter. This is 3 meter. This also we have 3 meter. This is 4 meters. So just check it. And angle we got 30.96. So we have this angle 30.96. So now this A, B, C, D. So we have this as A. So VA, HA. Then we have VD, HD. And this point we have B. This is C. So now we can go with moment about D equal to 0. So we have VA into 10 minus 6 into 7 minus 10 into 4 equal to 0. And we will have 42, 40. So 82 divided by 10. So we will get VA 8.2 kilonewtons. So value of VA, we have 8.2 kilonewtons. Now apply summation Fy0. So we have VA 1.8 minus, 8.2. VA we have 8.2 minus 6 minus 10 plus VD equal to 0. And therefore we will get VD equal to 7.8 kilometer. So VD 7.8 kilometers. Now we can find value of tension in the cable. Already I explained it in the last example. So we can have this. So summation. So joint we will consider. Joint A, this is 8.2 kilonewton. This we have HA. And then we have this force which will be TAB. Angle is 30.96. Question we have to determine reaction and HC. So we will have summation Fy0, and from this I can find TAB sine 30.96 equal to 8.2. And from this we will get TAB equal to 8.2 divided by sine 30.96. We have this value 15.94 kilonewton. So this is 15.94 kilonewtons. Then we have to apply fx0. I am making direct values. So we have HA equal to, now we have tension in the cable is 15.94. So we have 15.94 cos 30.96. And we will get HA equal to 15.94 cos 30.96. And we have value 13.67 kilonewtons. Now we have HA equal to HD. So now we have all reactions. This is 13.67 kilonewtons. HA also we have 13.67 kilonewtons. Now we are interested to find this HC value. Now we can find this angle theta, and after that we will get this value. Now we have this VD, we have this angle theta, and then we know we have cable, we are along this. So this angle we have theta, same. And then we can simply take tan inverse theta equal to VD upon HD. And then VD we have 7.8 divided by 13.67. And from this, I will get angle that is equal to shift tan inverse 7.8 divided by 13.67, and this is 29.71. See, we have resultant that is VD square plus HD square. So always keep in mind your reaction at D is always along the cable. If you will see first video, today we have solved one problem. And there we have this reaction along this. And therefore this angle we can have in this fashion. And now we know theta 29.71. This is HC. So I can write again tan theta that is equal to HC divided by 4. And from this we will get tan 29.71 equal to HC upon 4. And we will get HC value equal to 4 into tan of 29.71. That is 2.28 meters. So we have 2.28 meters. So reactions we have, and this HC value that is 2.28 meters. Likewise, we have to solve the problems related with cable. So now we will have next question, imperfect, perfect and redundant truss. I already explained this with example in last. If your members are less than 2j minus 3, so this is your imperfect. Then if M is equal to 2j minus 3, here we have 5 members. So this is perfect. And when we have M greater than 2j minus 3, so we are in this fashion, then we have this as redundant. So we have this as simple, we have roller. But right over here, M for 2j minus 3, 2 into 4 minus 3, 5. So we have M less than 2j minus 3. Here M is 4, 5. And 2j minus 3 we have same for all 5. And therefore M is equal to 2j minus 3. Here we have M6. 2j minus 3 we have same 5. And here M greater than 2j minus 3. And therefore redundant. So likewise, we have to answer the question. If you are not subscribed, subscribe YouTube channel Civil Engineers Technical Hub and see lectures related with mechanics. So now we will stop here only. Thank you.